This is Prince Patel, BTech final year student from the Department of Naval Architecture and Ocean Engineering from Indian Maritime University, Visakhapatnam. This video is prepared as the assignment of a structural and the foundation analysis online course provided by Skyfi Labs. I would like I would like to thank Skyfi Labs for giving me this opportunity. Now these are the main particulars. The beam and the column are M30 concrete. It has a longitudinal bar of HYSD 415, T bar of a mile 250, and a section having a dimension of 300 by 300 mm square. The slab is M30 concrete having a thickness of 150 mm. It is a 6-story building. Generally, the bottom stories are different from the other stories, so the bottom stories are kept here as 3 meters and the other stories are kept as 4 meters. The walls are drawn using auto draw cladding, and the loads which are acting, the dead load 3 kN per meter square, and on the roof it is 1 kN per meter square. The live load is 6 kN per meter square, and on the roof it is 3 kN per meter square. The cladding load is 0.2 kN per meter. So this is the model that I had drawn using the ETAB software. Uh, Firstly, we have to define all the beam sections. So and the materials of the beam and the column. So firstly, I had gone to the material. After going to the material, we had to add a new material if it is not given here. So I had taken 3 materials which are mile 250, M30, HYSD415. After defining the material properties, we have to go for the section properties, where we have to go for the frame section and add a new property, like I had added beam 300 by 300 and column as 300 by 300. After defining the beam and the column, then we have go to define the slab. Since the slab is 150 mm, so I had taken a slab of 150 mm thickness. After doing this, we have to assign the loads. So we have to go to the cell loads and put as a uniform loads if it is uniform, and put the dead load and the live load from here. Then we have to draw the walls here. So using the auto draw cladding, we can directly put the uh, buildings, and we can also provide the loads here. Once we are done with this, we have to go to the analysis and we have to run the analysis. After running the analysis, we will get all the shear forces along x direction, y direction, the movements, whether the member is all the members are failing or passing. We will now see that one. After running the analysis, we will see the deflection here. We can directly rotate this one to see which part is more dangerous. So the red part which are shown here, it has a deflection of about 26. So we have, since the deflection is more, there is a more red part, so these are the defective parts. So we have to provide the material of a high grade which we had put it. So we can, here from display we can see the other parameters also, like going to the frame and piers, and we can check the shear and all those things. So when I click on the shear, it will give the shear in the direction of, so this is the shear we are getting in the YY plane. So after rotating, I can show it. So this is the shear we are getting, and simply by putting the mouse cursor we can get the values. We can also check for the whether the component is failing or what. All the members are, so it has been showing that 215 concrete frames have been failed. So we have to change that one to a higher grade of, if we click on it, it can select all those parts directly. So this is the small video. I would like to thank again Skyfi Labs. Thank you so much. Thank you.